Hello everyone. In last class, we have learned some power formulas as well as Joule's law and heat generated also. Today, we will learn fuse wire. What is that? Fuse wire. So in most of the appliances, there will be a fuse wire. So whenever there is over current flow, first fuse will burst so that our device will prevent from the damage. Okay, that is the first reason why we are using fuse in electrical appliances. Got it? So let's see what are the characteristics and which type of wire we should use for fuse and other things. Okay, let's start. So this is fuse wire. Fuse wire. So first of all, it is made up from or prepared from, it is prepared from बोलेंगे. Okay, from tin lead alloy. Right? How we are making this? By using tin and lead. So in this there will be 63% tin and 37% lead. Got it? So if we will mix this amount of lead and tin, then there will be preparation of fuse wire. Now another one, it should have high resistivity and low melting point. This is very important. Why it should have high resistivity? Rho should be high. If resistivity is high, okay, and melting point is less, if current flow is high, heat will generate more, and therefore because of low melting point, that fuse will get melted and circuit will be open, and therefore because of that the device will get prevented. Keep it in mind. Therefore it should have high resistivity and low melting point. See here, let R be the resistance of fuse wire. Then we know what is R value. R is equal to rho L by E. Rho L by E. Now assume that this is a fuse wire like this. Yes or not? This is a fuse wire. You can see, right? So this is what, from this to this you are having some radius, and the area of this cross section A is equal to what you are getting, pi r square, and this is what the length of this fuse wire is. Got it? So can I replace here r is equal to rho L by pi r square? This is what I got, resistance of the fuse wire, where L is what, length of the fuse wire, you can see here, and r is what, radius of that cross section. Next one. Now heat produced in the fuse wire, if I want to calculate, what will be the case here? Now heat produced in the fuse wire, that is H, is equal to I square into R. But sir, before some time we have written power formula also, I square R, then H is equal to also I square R pi. See, power is what? Power is work done per unit time. Power is what? Work done per unit time. And here heat produced is what? H, and that is how much here? I square R. Okay. Now what I am doing, this R value I am replacing here, so therefore H is equal to I square into rho L by pi R square, which is equal to what? Rho L into pi R square. First note down this. So here we can say that this is heat produced per second, you know, because we are having formula H is equal to I square RT from the Joule's law. Clear? But why I am not writing here T? Because this is H by T, that is heat lost or heat produced per unit time, is equal to what? I square R. You can keep small or big, that is not the issue. Okay, understood now why I am using that formula? Yes, like this. So here T is equal to 1 second, and therefore heat lost or heat produced in the fuse wire, H is equal to I square R, that is unit time per second, we can say, or in a unit time. Therefore you are getting like this. Understood? Okay, next. Note down this. Next one. Now if H naught is heat loss per unit surface area. Is heat loss per unit surface area. Then per unit surface area is S naught. So for surface area, for surface area 2 pi RL heat radiated, therefore for surface area 2 pi RL heat radiated is equal to H naught into 2 pi RL. Yes. Now let us assume that this is your equation number 2 and this one is your equation number 1. Yes, H naught into 2 pi RL. This is complete H also I can say. And this one is also H. So at thermal equilibrium, both equations we should equate. So what is your equation number 1? I square rho L by pi R square. I square rho L by pi R square is equal to this H naught into 2 pi R. This L and this L will get cancelled. And this 2 pi R, if it is coming down here, that implies I am getting H is equal to, or H naught is equal to I square rho divided by this 2 will go here, pi into pi square. This is 2 pi square and this R square, so this is equal to R cube. So H naught is equal to I square rho 2 pi square R cube. So we got this value, that is what H naught. H naught is equal to I square rho divided by 2 pi square R cube. Let's keep it in a box. Okay, we got this. Next, after this, now according to Newton's law of cooling, from Newton's law of cooling, what we know, dq by dt is proportional to change in temperature. So dq by dt is what here, heat loss per unit time we can say. So can I write like this? H naught is equal to k into theta. You see here, dq by dt is proportional to change in temperature. This is what Newton's law of cooling. So here this is dq by dt. dq by dt is, if I am taking t as a 1 second, then this will become what? Heat lost or heat produced in 1 second. That is just not is proportional to theta minus theta naught, jo bhi hai. Or else you can say this theta is also what? Change in temperature only. Yes. So what is theta here? Theta is increase in temperature of fuse wire. Of fuse wire. Now what we will do? What we will do now? We will equate this H naught is equal to K theta. This is your equation number 3 and this is your equation number 4. So what I am doing now, from equation 3 and 4 here, from equation 3 and 4, what we are having, see, this and this should be equal. So here I square rho divided by 2 pi square r cube is equal to K theta. Where theta is what? Increase in the temperature of fuse wire. And if I want theta value, then theta is equal to I square rho divided by 2 pi square r cube into K. This we got formula for increase in temperature of fuse wire. Yes. So from this, what we can conclude, see here, for a given material of fuse wire, see from this expression what we are getting, I square is diagonal proportional to r cube. Keep it in mind. If suppose material of fuse is given, then because you see here this rho is constant, K is constant, this also constant, and if this theta is there, that is constant, then I square is proportional to r cube. Let's solve one problem on this. Okay, let's solve problem. A fuse wire with radius of 0.2 mm, a fuse wire with radius 0.2 mm blows off with a current of 5 ampere. The fuse wire of same material the fuse wire of same material but of radius 0.3 mm will blow off with a current of will blow off with current of. This is what the question is. So let's solve. Now read the question, see how much it is easy. If you will see, here a fuse wire with radius 0.2 mm blows off with current of 5 ampere. So what is given in this problem? What is the given? This is what I1. I1 is equal to how much you are having? 5 ampere. Next, you are having R1. R1 is what? Radius 0.2 millimeter. Next, you are having R2. R2 is equal to 0.3 millimeter. And he is asking what is the current at which this will blown off. What is the current at which this will blown off? Yes. So now only we have learned this. I square is directly proportional to R cube. Therefore, can I write like this? I1 square by I2 square is equal to R1 cube divided by R2 cube. That implies I1 by I2 whole square is equal to R1 by R2 whole cube. Clear? Yes, no. So let's substitute the value. First note down this and let's move ahead. Next. So therefore here I am getting I1 by I2 is equal to R1 by R2 and taking this cube root we can say that is what? 3 by 3. You know? I1 you know how much? 5. I2 do you know? Don't know. R1 0.2 and R2 is 0.3. No need to convert into meter. Why? Because whenever they are giving ratios like this, no need to convert, because even if we have converted into meter, this minus 3 and this minus 3 will get cancelled. So no need. So let's move ahead. So this is 5 by I2 is equal to, this is nothing but 2 by 3 we can say. So 2 by 3 whole power 3 by 2, because what I did multiply and divide by 10 inside square root. देखो अब इसका कितना आता है स्क्वायर रूट, कितना आएगा इसका क्यूब रूट, how much we will get? This is 8 and this one is 27 है ना. So this is 8 by 27 under root. Yes, because first what I did, I took cube and then square root. So I am writing 8 by 27 whole power 1 by 2. If you want one more step like this. Now next. Now take reciprocal. This is I2 divided by 5 is equal to 27 by 8 and I am keeping under root. So therefore, the current at which this will blown off is 5 square root of 27 by 8. Yes, if you want to find this square root, you can do it. 27 by 8 you are getting 3.375, and its square root you are getting 1.83. So therefore you are getting here I2 is equal to 5 into 1.8, that is equal to 9.18 ampere. 9.18 ampere. Got it? Just check, do it yourself. From here only you can do. So note down. Note down. Okay, next. Next one, some note points regarding the power. Note point for power, A bit. Now see here. I am showing one small diagram also. Series and parallel. What happens? I am taking two resistance only for understanding. This is just for understanding. Here it is R1, here it is R2. This is also R1 and this is R2. In series combination, what happens? See, I is same. Obviously, already we have learned in resistances in series and parallel. So, power P is proportional to R with V is proportional to R. So here, potential difference and power will be more in larger resistance. Clear? I is same, P is equal to what? I square R, V is equal to IR. So power and potential are directly proportional to resistance. Got it? What is that? In series combination, power is direct proportional to resistance and potential is also direct proportional to resistance. So potential difference and power will be more in larger resistance. More the resistance, more will be the power. More the resistance, more will be the potential difference. Okay. In parallel, what happens? See here. In this case, phi is same where in this parallel. So power P is inversely proportional to R because power formula is V square R by R here, and I is also inversely proportional to R. Okay, and therefore potential difference is same, no doubt. So here what happens? More will be the power in small resistance. Small resistance, small resistance, more power. Okay. In series combination and in parallel combination. What happens? In series, if resistance is more, power will be more. But in parallel combination, the one who is small, there will be the more power. Keep it in mind. Shall we solve one problem on this? Okay. Okay. Ahead we will get some problems. Wait. Later we will solve. Just for the time being, you keep it in mind. This one. Next. Next point. That is B I am taking. If n equal resistances are connected in series, if n equal resistances connected in series with a voltage source across voltage source, that is V, then power dissipated PS is equal to V square by R into N. Why? Because how many resistors we are having? N resistors. So here RS is what? N into R. Therefore I have replaced this. If you want one more step, you do like this. Because how many resistors we have connected? N number of resistors. So this is what power PS is equal to V square by RS, and that is equal to V square by N into R. So you know this RS is equal to R1 plus R2 plus so on plus up to Rn, and all are equal. Therefore, Rs is equal to N times R. Got it? Next, if in this only, if same connected in parallel. Now what we did? All these resistors we have connected in parallel. So obviously here what we will get, power in parallel combination is equal to V square by Rp. So you know Rp for equal resistors, what you are getting, R by N. Substitute here, what you are getting, V square by R by N, and therefore power in parallel combination is equal to N into V square by R. Got it? Suppose this is you got equation 1 and this is your equation number 2. Then see here, from equation 1 and 2, what you are getting, PS divided by PP, that is power in series combination divided by power in parallel combination. Just divide this, P square by NR divided by N V square by R. This R and this R will get cancelled. This V square and this V square will get cancelled. And this is equal to, this N is coming down. Yes. So you are getting 1 by N square. And therefore, can I write like this, power in parallel combination divided by power in series combination is equal to N square. If they are asking ratio, you can direct use this formula. But keep it in mind, N equal resistors should be connected in series and parallel. Then only you can use this direct formula for finding the ratios of power. Clear? Yes. Note down. Okay, next, let's move ahead. Now, one more note point. Next one. C point. Resistance of given appliance, given electric appliance. R is equal to Ps by I. And here this Ps is equal to I is equal to W by Ps. So that is equal to Ps square by W. How you got this? See here. Phi is equal to IR, you know, Ohm's law. So here phi is equal to IR, therefore R is equal to Vs by I. And here this W is what? We can say power in a watts. Okay, power in a watts. So therefore this is W is equal to Vs into I or V into I. Just substitute that values, you will get the answer. Here this is W is what? Power in a watts. That's why we are denoting with W. So if you want resistance of any appliances, you can calculate by this formula. Yes, A square by W. So here this Vs is Vs and W, I can say. Vs and W are voltage and wattage. voltage and wattage specified on the appliance. Sir, can you tell one example? Yes, sure. See here. One common example I am taking. Let us suppose we are having a bulb. फुग्गा. ये तो फुग्गा हो गया. रुको. Wait. Something like this. You can assume. Okay. And no. So on this there will be written things like this, but there will be written on the board or this bulb, but there will be written something like this: 60 watt, comma 220 volt. This is specified values. Specified on bulb. You can see any electric appliance, there will be like this: 60 watt and 220 volt. So how to find resistance here? Vs square by W. Vs how much? 220 square divided by 60. So if we will do this, how much you are getting? Check it. You are getting something like this: 806.6 ohm. Understand? Okay, so they will be like this specified values, and from this, if you want to find the resistance of that particular electrical appliance, you can use this formula like this. Understood? Check it. Check it once. Okay, good. Note down this. Okay, next. One more note point you can see here, which is very important. If applied voltage is different than specified, then actual power consumption, then actual power consumption, P is equal to PA square by R, है ना? Power P is equal to V square by R. This is A is what? Applied voltage, and here A is equal to what we are having, or this R is equal to what? This is Vs square. R is equal to Vs by W. Yes, Vs by W, and that is equal to यहाँ पे Vs square आएगा ना? Yes, Vs square by W. So you are getting this as a resistance value. You see, Vs square by W, because power is there, no? Power P is equal to V square by R. So if I am taking this as a W, then W is equal to, this is P square by R, and that implies if I want resistance, then resistance is equal to what? Check it. Ps square by W. है ना? Therefore, I am getting this here as a square. Keep it in mind. So I am writing here what? Vs square by W. And now this Vs square is down only. Vs square I am keeping here at numerator. Vs square by Vs square into W. Let's see one example. Let's see one example. Again, I am taking the same bulb which we have taken before, right? And on this, there is a rating. What is that rating? 60 watt, 220 volt. But we have operated at VA is equal to 200 volt. Then power consumption in this case, power consumption P is equal to VA square means this 200 into 200 divided by V supplied. V supplied means V specified, we can say. Specified means this one which already printed on this. So this is applied means supplied and this is specified. PS for specified. So you write here how much 220 into 220 and how much watt is denoted here, that is 60. So do this, how much you are getting? These two zeros will get cancelled with these two zeros and you are getting 200 into 2 into 60 divided by 22 into 22. Now do this and check how much your power consumption is. Do it, check करो एक बार. You are getting 49.58 watt. How much power you are getting? Check करो. Power P is equal to 49.58 watt. This is what actual consumption of power when we are using it at 200 volt supply. Check it. Yes, 49.58 watt. This is what the power consumed is. You can see. Check करो. Got it? So let's stop here for today. Right? So in tomorrow's class, we will see bulbs connected in series and bulbs connected in parallel. And we will solve some problems on this power concept. Right? So we'll stop here for today. Enjoy the day. Bye.